Bismillahirrahmanirrahim. Welcome to the lecture on file system interface and disk allocation methods. So in this chapter we are going to see how a file would be stored in a secondary storage device such as hard disk. So you are going to see how a file logical unit of storage, that is file, is mapped onto a storage device. So this functionality is done by a module in the kernel called as file organization module. So file organization module maps the file into the storage device. So before we start the discussion, let me give some background information about a hard disk. Anyhow, you will learn that in the chapter 12, but for this chapter I want to give some basic information about the structure of a hard disk, so that it would help you to understand the disk allocation technique which we are going to see. So this is a structure of a disk. So in this structure you can see, three platters. So this is called platter. So we have here there are three platters, and each platter has two surfaces, top and bottom surface. So each platter has two surfaces. So here how many platters are there? Three platters, and you can see 6 surfaces. Okay, so each surface of a platter is divided into concentric circles called as tracks. Okay, so this is a track. So you in each surface of a disk there would be many tracks. Okay, track 1, track 2, track 3, track 4, track n. There would be many tracks. So once again, these tracks are divided into smallest unit of storage called as sector. You can see this block, it's a sector. It's the smallest unit of storage. Usually it would be around 512 bytes. So just to recall the structure, so the hard disk usually have internally many platters. Each platter would have two surfaces, top and bottom, and the surfaces are divided into tracks. Okay, the tracks are divided into sectors. So the sector is the smallest unit of storage. So for example, when we want when any application wants to save a file into the disk storage, the file would be distributed across many sectors. Okay, because each sector would have 512 bytes size. So a file, for example, let's say 1 KB would consume 2 sectors approximately. Clear to you? So whatever files which are saved onto the disk would be distributed across many sectors. So that is what we are going to see in this chapter, technique of disk allocation, how this disk surface is distributed to the application. So this is what we are going to see in this chapter. They are called as disk allocation techniques. So the disk is made up of smallest unit of storage, which we can call it as sectors or blocks, and a file is a logical unit of storage. So in this lecture we will see how a file is mapped into the secondary storage device, and how the disk blocks are allocated to the files. So in this lecture we are going to discuss 4 disk allocation techniques. They are contiguous, linked, file allocation table and index allocation table. In the contiguous allocation technique, each file occupies set of contiguous disk blocks. So actually, let us say a file count here. Okay, it is starting block is 0 and its length is 2. So it uses 2 blocks. So its starting block is 0 and it extends up to block 1. So here the file is contiguously stored on the disk. Such kind of disk allocation technique is called contiguous disk allocation technique. Let us do a simple example. The file alpha, the starting block is 0 and its length is 2. So alpha the block 0 is allocated to block file alpha, then block 1. Next, let us say beta, its starting block is 14. So beta, the block 14 is allocated to the file beta, then block 15 and then 16. So its starting block is 14 and its length is 3. So here you can see the files, they get the disk blocks contiguously together. The file alpha as well as the beta, they get the space contiguously in the disk storage. So what is the advantage? We have discussed this in the chapter number 9, sequential access and random access. So this technique, contiguous disk allocation technique, is good for sequential as well as the random access technique. And the problem with this approach is it suffers from external and internal fragmentation. So what is this external fragmentation? You can see here the files, according to this disk allocation technique, needs the disk space contiguously. So we have some free spaces in the disk, okay, and these free spaces are not contiguous. Suppose, just assume a file has to be stored in this disk, and the file can be stored in the disk using all the free spaces, but since the free spaces are not contiguous, they are not together, the file cannot be stored even though there is free space, but these free spaces are not contiguous together. So this problem is called external fragmentation. Just recall the external fragmentation problem what we discussed in the memory management technique. And similarly, this technique also produces the internal fragmentation problem. So basically some of the blocks will not be completely used by the file. So some spaces within these blocks would be wasted, and this wasted space is not allocated to another file. So this problem is called as internal fragmentation. So the advantages are, it is good for sequential as well as random access. Contiguous allocation technique is good for sequential as well as random access, but it suffers from internal and external fragmentation. So next disk allocation technique is linked allocation technique. In the linked allocation technique, each file is a linked list of disk blocks. The directory entry contains a pointer to the first block of the file. Each block of the file contains a pointer to the next block. So let's discuss this now. So this is the directory table. In this table we have a entry for a file zip. The zip file entry has a starting block pointer to the starting block of the file and the ending block. So this file, the first part of the file is in the block number 9. Okay, so the file needs many blocks. Okay, many blocks. The first part of the file is in the block number 9, and the second part of the file is in the block number 16. So you can see each block stores not only the data, but also it stores the pointer to the next block in which the file is continued. Let me repeat. Each block not only stores the data, but also it stores the pointer to the next block of the file. So the directory table entry for this file has the pointer to the first block. So from this we can understand the file first block, logical block, is in the block number 9. Okay, now in the block number 9 the system can access the data, and then the next part of the file, okay, this block has the pointer. So from this, using this pointer, it goes to the next block of the file, that is block number 16. Then here after accessing the data, there is a pointer to the next part of the file. So it is block number 1. Then the next block for this file is block number 10, and the next block is, the last block is block number 25. So the directory table also has the pointer to the last block of this file. So in this approach, there is no external fragmentation, and the files can be arbitrarily big. Okay, so it can be of any size. The files can be of any size. There is no external fragmentation. You can see this file is distributed across many blocks in different places. Okay, and these blocks, the files in the disk, they are not stored contiguously. Okay, just compare here. Here the file is stored contiguously in the disk, whereas here the file is not stored contiguously, it is stored in different places. Okay, so this approach actually eliminates the external fragmentation problem. And the disadvantage is it is very effective for sequential file access while it is compared with the direct file access. Okay, so it is very efficient for the sequential file access. Why? Because you can see there is a pointer. Okay, so using the pointer, just we can follow to the next block of the file in the disk. So this is good for the sequential file access. And another important drawback is each and every block stores the data as well as the pointer, because each block has the address of the next block in which the file is continued. So some space is used for the pointers. And once again, the internal fragmentation problem it exists in this approach also, linked allocation technique. And then reliability. Suppose if one block is corrupted, and then the link of the file would be lost. If one or two blocks is corrupted, then the link of the next blocks for the file would be lost. So the reliability is a big question here. Then the next disk allocation technique is called file allocation table. It's a variant on the linked allocation scheme. It is based on the linked allocation scheme. So in this file allocation technique, there are two tables. A table is created at the beginning of each partition with an entry for each block in the partition. A directory entry for a file specifies the block number for the first block of the file. The value of the fact entry for the first block will identify the block number of the next block in the file. So what is explained here is this. There is a directory table, already you know that. Okay, it's a table in which all the information about a file exist. So this table would have the information about the file. Example, this is a file, auto exec dot batch file, batch file. Now this file, same like linked allocation technique, the file would be stored in many disk blocks in non-contiguous manner. Okay, here also you can see in the linked allocation technique, the file is stored in non-contiguous manner. Okay, just recall here the file is stored in contiguous manner. However, the problem with this disk allocation technique is that it is good for sequential search and not good for direct file access. So this file allocation table is just a variation, a modification of the linked allocation technique. It is based on that. Okay, so in this, the directory table would have the information about the file and would have an entry of the first block of the file. Okay, so the first block of the file, the block in which the file is beginning, the first block of the file, that information would be here. So from then what about the file would be using more than one block, right? So the pointer to the first block is available here, but what about the other consecutive blocks? What about the other blocks? So there is another table that is called file access table. Okay, so this file access table would have the information about the file's other disk blocks. Okay, so the directory table would have the entry for the first block, the second or third, the next block, that information would be available in the file allocation table. So let us see this example. So the auto_x.bat, the first block is block number 2. So the block number 2 would be available here. Okay, so the first block of the file is block number 2. Then what is the next block? That information would be available in the file allocation table. So the next block in which the file is stored is block number 4. So the next part of the file is in the block number 4. Now the next part of the file will be available in the block number 8, and the last part of the file will be in the block number 6, and block number 6 is the end of file. Okay, so autox.bat, okay, there is an entry for the first block of the file. So let us say the first block of the file is block number 2, pointer to the first block of the file. So there is the pointer to the first part of the block of the file, so block 2. So here the file allocation table has the entry which shows the blocks in which this file is continued. So the next part of the file is in block number 4, and then block number 8, then the last block is block number 6. Okay. Similarly, let us say this file autox.bat, it is in block number 1, the first part. So the second part of the file is in block number 3, here block number 3. So block number 3, and then the next part of the file is block number 5. So now the block number 5 is the final block. So the file autox.bat, okay, for this the block number 1 is allocated, then block number 3 is allocated, and block number 5 is allocated in the disk. And you can see this disk allocation is not contiguous, and also this, the benefit of this technique when compared with the linked allocation technique is it is same like linked allocation technique, but it supports the direct access also in a better manner compared to the linked allocation technique. It's better for the direct access also. So the disadvantage for this disk allocation technique is more head seeks. So what is the head seek that you will see in the chapter number 12? So the head, actually the movement, the distance the head moves in the hard disk. Okay, so this is the head, read write head. So this is the platter. Over the platter you have many tracks. Okay, so tracks are divided into sectors. So whenever any data has to be read from the disk, the read write head has to move from one track to another, and it has to place its head above the sector to do the reading or writing. Okay, so this spindle, this platters would be rotating around this spindle. Okay, so the read write head, what you can see here, it will move from one track to another. Like let's say this is track number 1. Okay, track 0. Then let's say this is at the edge. Okay, here at the edge of the platter, let's say track N. So the read write head, okay, would move from one track to another like this. Okay, so when the amount the distance, amount of distance the read write head covers, if it increases, then excuse me, just a minute, it would increase the seek time also. Where is that? Okay, head seek time. So here, as far as this technique is concerned, the head seek time is more. Okay, it can be reduced using the caching technique. okay, by caching the fat entries. This is the fat file allocation table. This entries has to be cached in order to reduce the seek time, in order to reduce the head movement. So this head movement you will understand very clearly in chapter number 12 when we solve the disk scheduling algorithms, various disk scheduling algorithms. Okay. So next we will discuss the indexed allocation technique. Now let us discuss the indexed disk allocation technique, indexed disk allocation technique. So in the indexed disk allocation technique, each file has an index block containing a table specifying the physical block for each logical block. The directory entry for a file contains the address of its index block. So there is a block called index block which is allocated to each and every file. So each and every file, okay, in the directory table is associated with a block called index block. So for the file zip, let's say this is the index block. So this index block will have it will store the information about the different other blocks in which the file is stored. Let's say the file is stored in block number 1, block number 9, block number 10, block 16 and block 25. So these informations are available in the index block. Okay, so let me remind, so according to this indexed disk allocation technique, the directory table entry would have an entry for a index block. So that index block has the information about other blocks in which the file is stored. Okay, so this is the enlarged okay enlarged information about the index block. Okay, now let's say we have some examples. Okay, so let's say the file beta in the directory table has a associated index block. So index block is 20. Okay, so this index block 20, okay, will have the information about other blocks in which this file is stored. Let's say here you will have the information such as 5, okay, 15, 24, 31 and 1. So what it indicates is that the next part, the file, okay, is stored in the block number 5. Okay, and then 15, then 24, then 31 and 1. So this index block basically stores the information about the other blocks. This is how the index disk allocation technique works. The advantage is it's good for direct access, and there is no external fragmentation. Of course, there is the files are not stored contiguously, they are stored in different places, different blocks, okay, in non-contiguous manner. So there is no external fragmentation, and there is internal fragmentation, okay. And okay, some amount of space is wasted for, so some amount of space is allocated for the index block, okay. In some situations, here there is only single level index block exist. In some situations that we will see little later, using a concept called inode, there can be multi-level indexed, okay, block that can exist. So some space is allocated for the index block, and also the head seek, okay, the amount of distance the head moves while accessing the data, okay, while doing reading or writing operation for a particular file using the index allocation technique, okay. Sorry, when index allocation technique is used, the the head seek for read or write operations would be more, okay. So what is a head seek exactly? Again I repeat that we can see in the chapter 12. So finally we are going to discuss about the inode. What is inode? Just now we completed the concept of indexed disk allocation technique. So this is the index block, okay. So in Linux operating system, in Unix operating system, this index block is called as inode. Is it? So this index allocation technique, okay, the very important part is this index block. So in Linux or Unix operating system, this block is called as inode. So what is inode? Okay, Unix index block. So in Unix operating system, okay, index blocks is called as inode, okay. Now let's say so I am in this present working directory ls-al or we can say ls-l. So we have these files here. Now I want to know, as far as the index disk allocation technique, each and every file is associated with the index block, correct? So this index block in Unix or Linux operating system is called inode. So that means for each file there should be a inode block, okay. Now in Linux operating system, let's find the inode for each and every file. So we have so many files here, okay. So ls-i for inode, l, then there is a file a.c. So for this file a.c, the inode number, that is the index block, each and every inode has a number, identification number. In Linux or Unix operating system, please understand, there will be many inodes available, okay. There will be a table, that table will have the list of inodes. For example, this is a command So this command will find the complete file system information about this partition, SDA1 partition. So here you can see in this partition there is around 10,000, 100,000, around 1 million inodes are there. Just a minute, let me check properly the count. So around 1.4 million inodes are there in this particular partition. Why? Because for each and every file inode is allocated. So this inode will store the information about the file. You can ask a simple question: does the inode store the data? Okay, the file, actually we have files, right? For example, this is a file. This file you have lot of data, right? So now if you store this in the disk, these data are stored in the index block or inode block? No. So they are stored in data blocks. They are stored in data blocks. Okay, the information about the data blocks in which the file is stored will be stored inside the index block, or we can call it as inode block. So please understand, the inode block will not have the data. It will have the information about other blocks which stores the file data. You understand? Okay, so now, so in each and every partition, please understand, there are many inodes already created when the file system is created, and whenever a file is created, that file is associated with a inode number. For example, a.c is associated with the inode, this inode. So when the system opens this inode and access the data, it can find that the block numbers in which this file is stored. This file may be using it may be using a single block, or it may be using more than one block, right? So just assume it is using around 10 blocks. So all the information about that 10 blocks will be in the inode, and the identification number for that inode is this, for this particular file. You get the point? So what is the inode? Okay, in Unix the index block is called as inode. Okay, now there is one more command, stat a.c. Now you can see it will give more information about the inode. Okay, just now I said this is the inode. Okay, so this stores the information about the file, and also it stores the information about the different blocks in which the file is stored, correct? So now we want to know the complete information about a particular file, inode information for a particular file. So the command is this, stat space the name of the file. If you give it will give full information. The file name is a.c. So all these informations are stored inside the inode. Okay, and then the size of the file, how many blocks it is using. Okay, then is it a file or a directory folder? It's a regular file. Okay, how many links? This we discussed in the file system first part. Okay, and then access permissions, read, write, all these permissions. Okay, so then inode number, clear? So these are the information, different informations which are stored inside the inode. So in that, the very important informations are this. Okay, which user created the file? Okay, group, we can put the users in groups. Example, students group, teacher group, like that. Okay, so let's say this file belongs to the user, this user, and the group name is given here. Okay, and this is the user ID and this is the group ID. Okay, and then what is the size of the file, okay, how many blocks it's using, is it what type of file. So these informations are here, and okay, let's see this. So this is the information, okay, which I showed you here. You get the point? So the command is state.a.c. So students, once again let me tell you, no need to memorize this command. Please try to understand the inode in a practical way, okay, practically how to find the inode of a particular file, okay. So this is what you should know, but as far as the theory exam is concerned, please don't worry about the commands. You need not memorize, okay, the commands. Just try to focus the concept here. Is it clear to you? So whatever you are seeing in this slide is what I showed here practically. These are the informations, okay, for that is stored in the inode of a file, okay. So mode means is it a file or a folder. Owners means like user ID, group ID, you saw that right here, okay, you saw that here, okay, user ID, okay, user ID, group ID. Is it a file or a folder? Let me show one more example. For example, this is a folder, okay. So stat beta, you can see it is directory here. So that okay, here given as mode. Timestamp, when okay, you can see the timestamp, what time it is modified, what time it is accessed, okay. So then size of the block, then count how many blocks, you understand. Then we have something here extra. What is this? So the inode can have a direct block or single indirect or double indirect options. What is this? So what you are seeing here is direct, that is so this inode has the, suppose if the inode has the information about the data blocks, okay. So like this one. So here okay, the inode has the information about this data blocks, you get the point. So this is called direct, okay. But there is a variation, that is sometimes this inode will point to another inode, and that second inode will have the information about the data blocks. This is called single indirect. Then double indirect means it is like this, okay. So the directory table will have a pointer to a inode, and that inode will have a pointer to another inode, second level inode, and that second level inode will have the information about the data blocks, okay. So this is another variation. Similarly, you can have like triple indirect, that is 3 levels of inode. Do you understand? If you want to store more information about a file, then you can expand the levels. The operating system would the file system would expand the levels for the inode. You get the point? But I don't want you to confuse too much. Just try to understand. Inode basically stores the information about a file. You get the point? So please don't worry about single indirect, double indirect, triple indirect. Just try to focus here. Okay? Just inode will store the information about a file. You get the point? This inode is nothing but index block, and each and every file has a inode associated with it, and each and every inode has a number, identification number. Is it clear to you? So in the directory table, example in the Linux operating system, a file is associated with the inode number, okay. So when the operating system, it will go to that inode and it will find the information about different data blocks. Is it clear to you? Okay. So now what you have to learn is, what is inode? Inode is nothing but, okay, index block in Unix operating system. It can have different levels like single or double, like that. Is it clear to you? and this inode stores the information about the file. What kind of informations? Is it a file or directory? Which user created, or this file belongs to which group? Okay, timestamp, like when the file created, when the file was accessed, size, okay, count, how many blocks. So that kind of information. Is it clear to you? And the command, what you should know for practical purpose, students, stat space a dot, that is the file name, or you can give this command also if you don't want more information, ls ls space hyphen I, okay, this one, okay. So hyphen il ls list, okay, list ls hyphen il, okay. So this will give the inode number of a particular file. If you want more information, you can go to this this command. Okay, students. So with this, I conclude the lecture 10. Okay, file system interface and disk allocation methods. Thank you very much.